In this video, I'll be talking about the mechanism that works to solve this problem, given only some source of acid. So why don't you guys go ahead and try it yourselves real quick, and then we'll walk through it together. Okay, so for this problem, it's best to start with the highest energy thing when considering mechanisms. The highest energy thing here is going to be our acid, so the H+. So the only thing that's reasonable to assume our acid is going to protonate would be something that has that set of electrons, or the lone pair right there. It's going to be unreasonable to suggest something that's in the pentane ring. So let's go ahead and draw what that becomes over here. From this point, we now have to find ways to satisfy this charge. So we're always going to be doing stuff with the highest energy thing. In this case, that would be the only thing that is charged now. So let's go ahead and satisfy that charge by breaking that single bond and giving the electrons to that oxygen. So when we do that, our intermediate next will look like this. At this point, we've come to this part in the problem, and now we get to just move around charges until we can get to what our product looks like up in green. So we're going to move this carbocation just by doing a simple carbocation rearrangement. We can suggest this right here, and that'll move our positive charge to be adjacent to that other oxygen that's in that 5-member ring, and that'll become helpful later in the mechanism. So here's the intermediate of doing that. So from this point, now it becomes a little bit more clear what we need to do, and that's going to happen by, excuse me, let me get the correct color. So if we let the lone pair of electrons on this oxygen come and attack that carbocation, we will get our next intermediate, which looks very close to our product. So here's our final intermediate before our product. And just a real quick note, I went back and I colored this last hydrogen red just to be consistent. But from now, at this point, to get to our product, we can just assume that the conjugate base of whatever our acid was is floating around in solution. So I'm just going to designate that by a capital B with some electrons. So that's floating around in solution. We can see that the base will come, pull that proton back off, give the electrons back to the oxygen, and that'll leave us with our final product.